Welcome back to the boat sheet. Over the next few videos we're going to be looking at propellers, and in particular comparing the standard prop fitted to our Sun Odyssey 349 with the Brunton prop, which is reputed to improve handling both under motor and particularly when motor sailing, and giving much better economy and a quieter motor sailing. So we're going to start with unboxing it, having a look what comes in the box, and we're going to move on to look at how it works, and then we're going to do some comparison videos. I'll leave that there. The manual, there's a couple of bits and pieces in there which we'll look at in a minute. And here's the thing itself. Here's the propeller. And the first thing to say is that the back end of it, the business end going onto the shaft, is exactly the same as our existing prop. It's a 25mm shaft in this case with a keyway. So the idea is our other prop comes off, we make sure that this is a snug fit, it goes back on. The engineer is going to fit it, tells me that it's important to get this exactly right. So he's going to be doing that for me. I'm not going to have a go at doing that myself, although I do believe a lot of people do them themselves. So turning the prop back over then, this is the big difference. Of course, these blades are free to rotate. Now the idea is that each of them is mounted on ball bearings here. This way it's easier for you to see. The idea is that each of these are free to rotate on these ball bearings mounted inside here. You can see there are two covers, one here, one here. These are the caps over the grease points, and I believe you take these both off. You screw an adapter, which is in the bag there, into one of them, and you pump grease in, and when you see clean grease coming out of the other hole, then you know you've flushed it all out. On the back end of the prop, we've got a specific zinc anode, which has got 3 mounting holes. They look pretty standard, and interested me that they're nylon bolts, but I'm guessing that's to prevent electrolysis. No doubt the people at Brunton will be able to tell me, or you'll be able to tell me in the comments. So if you've got a Brunton prop, or if you've heard about Brunton props and you have opinions on them, do leave comments, because we're going to be trying to figure out whether they are worth the money, because they're expensive. Are they worth it? Well, if it means that we can motor sail on those days when we need to with the engine running more quietly, then yes, definitely. If it means that we can back down more quickly and change direction more quickly, then I guess that's a bonus too. But the big thing for me is on those days when there's light winds and you're not getting the speed you need to get to a tidal gate, and you need to motor sail, on those days, to be able to motor sail and get better speed with lower RPM will be worth it. So we'll see. Let's have a think then about how the propeller actually works. Well, the first thing to note is that the centre of gravity of the blade is over here somewhere, but the point of attachment is over here. So we've got a couple being created immediately just by virtue of the fact that we're rotating it and it's off centre. There are some other forces involved as well though. When there's a little bit of pitch on the prop, like about here, the centrifugal force acting through the leading edge is on a different plane to the centrifugal force acting through the trailing edge, and they're both on a different plane to the centrifugal force acting through the centre of mass of the blade. Because of that, and because everything is revolving around the centre of mass, this difference is going to create what's called a centrifugal turning moment, and it's going to try and make the blade change pitch. So that's one force. The next force acting on the blade, of course, is just water pressure. So as the propeller turns, water's hitting the leading edge of the blade here, and to start with it's going to be hitting aft of the blade as it first hits, and it's going to be causing the blade to fine off. Now as it fines off, that's going to be causing the centre of mass of the blade to change in relation to the centre of attachment to the hub. And this is the point at which it's being pulled. Now, the clever design of this blade means that at the optimum angle of attack for the leading edge of this propeller blade, it's all designed so that the balance of CTM, centrifugal force, and water pressure, and the couple created by the centre of pressure versus the centre of attachment to the hub, all causes the blade to go to exactly the correct pitch, or thereabouts, for efficient operation. What that should mean is that you get smaller tip vortices because we haven't got an angle of attack that's too big. And the bigger the angle of attack, the more the vortices around the tip are. we should get better water flow with less breakaway and less turbulence, which means more efficiency and less energy wasted in stirring up water. And that should mean that we can move through the water faster with a lower RPM. So it looks like it should work. Let's test it in practice to find out if that's true. To do that, we're going to do some timed runs and we're going to measure the boat under power both ways to see what RPM gives us what speed. We're then going to motor sail with the sails set up to give us just 2.5 or 3 knots of forward speed with an 80 degree or so relative wind. And then we're going to start the engine and we're going to compare RPM and stable speeds to see with the standard prop and the Brunton prop which one gives us the best speed for the lowest noise level. Now I'm working on noise level because that's the win. If you're motor sailing, the one thing we all hate when we're sailing is having to start the engine, and it's the noise that bothers us, not the fuel. Now, yeah, saving fuel is a great thing, but what we're really trying to achieve here is more enjoyable sailing. So we're going to use a decibel meter, and we're going to have an accurate measure of the actual noise levels in the cockpit based on the standard prop and the Brunton prop being used to motor sail. The last test we're going to do is backing down. So we're going to back down from normal 80% wide open throttle forward speed. We'll find out what that speed is with standard prop and we'll then recreate it with this prop. In theory, that will mean a lower RPM because this in theory should make us go faster. And we'll then back down from that point and we'll time it to the point at which we're stationary or going astern so that we can see which one gives us the best manoeuvrability. So stick with us over the next few videos and we'll see whether it's worth the substantial, if I'm honest, investment in buying this propeller. The other items in the box are the Autoprop user manual, which has got details of how to fit, remove and maintain the prop. Some Loctite for use on the locking screw which goes onto the prop attachment nut, and the little adapter which is used for greasing the bearings when the boat's taken out of the water. What we're going to do now is just have a little look at each page of the manual so you can freeze and a screenshot if you like. I do believe this manual is also available on the Brunton website. I must say at this point that this is not a paid promotion. We paid full price for this propeller and we are simply looking at it so that other users can see whether it's worth them spending the money. And if you have a Brunton prop, please do comment below. Tell us how you get on with it. Do you find it makes life better for you when you're motor sailing, when you're motoring, when you're manoeuvring? We'd love to hear your comments on the prop. Thank you. Thanks for watching the video. If you like it, don't forget to hit subscribe and to hit like, which will help us to make more just like this.